Matt Turek. I'm going to talk to you today about large-scale understanding of crowdsourced videos. This was joint work done in the computer vision group at GitRab. There's lots of video on the web. The question is, what does it contain? Can we use it for intelligence purposes? So for instance, these videos contain complex events, things like flash mobs, weddings, or birthday parties, and characterize relationships between places, people, and things. They also provide indicators of population sentiment. So for instance, it can characterize the level of violence or peacefulness for a demonstration. So this speaks towards understanding internet video relationships. The question is, can we do this automatically? The way we can do this is by expanding on a set of features which characterize video. We build from a very low level using image edges and histograms of them to characterize objects and image texture. We can also track feature points in video to characterize the motion of objects in the scene and the camera. On top of these low-level representations, the research community has built things like Object Bank, which characterizes a few hundred objects, and Action Bank, which characterizes activities and behaviors in the scene. We can use this information to start applying attributes to a scene to characterize whether they're indoor or outdoor, the types of light and the viewpoint. And then putting all these together, we can start semantically decomposing an internet video. So for instance, we can detect that there's an object, a car in the scene, that there's a person interacting with the vehicle because of their proximity to it, that there's perhaps a tire nearby. So we've used this to build a system for indexing internet videos. These are the results from that system, the top 32 results when you query for a flash mob. So the precision in the top 32 results here is about 96%. As you start getting lower in the result set, you still maintain a reasonable average precision, which is about 74%. So I would claim that this is a useful level of performance for an intelligence analyst. This is within an archive containing about 26,000 videos. It was not constructed at Kitware, but is relatively representative of the videos on the internet at large. And just looking at these flash mob results, you'll see that there's a large diversity in terms of the content just within the single class. There's different viewpoints, different densities of the objects in the scene, which makes it challenging. We've also looked at moving beyond purely linear presentation of results in analysts. So here we're exploiting a graph-based representation where the nodes in the graph are images or videos, and the edges exist if two items are similar. And we can characterize that similarity in the relationship and cue the analyst in different ways, perhaps by using color or edge thickness, or by putting videos that are more similar closer together. So on the left-hand side, you see an initial clustering of results. There's really two modes in this cluster, and then as you zoom in, you can see the graph of the relationships within that cluster, which allows an analyst to understand in more detail the set of results. We've also leveraged this graph-based representation to do interactive query refinement. This is a process that allows the user to provide feedback on each of the results if they're semantically relevant to their particular search or not. So this allows them to train the system to their particular query. So it's very difficult to do the video understanding in general, but having the interactive query refinement process allows the analyst to hone in on a result that they're looking for. We've also leveraged this graph-based relationship and added motion to it. So an analyst can adjust the weights of links in the graph to examine relationships. So for instance, they can start analyzing the impact of different features and how it characterizes the relationships between the videos. Because often videos will have characteristics of multiple event types. For instance, on the right-hand side, you see the orange cluster that lives between wedding ceremonies and feeding an animal and attempting a board trick. So with the ability to interact with the graph dynamically, it provides much more feedback, much more information for the analyst as they're exploring the result set. So the takeaway here is that large-scale internet video understanding is ready for focused operations. We can provide a reasonable level of performance that's useful and much better than having an analyst try and go through and look at thousands of results without computer queuing. We can find complex events, we can find objects and the links and understand the relationships between them, and we can also effectively visualize and browse these large internet video collections and the query results. Thank you.